And to kick us off, we have Philip, who has made a very interesting web-based modular synthesis project that he's going to tell us a little bit about.
Thank you, Alex. So welcome, I'm Philip, and today I'm going to show you two things. Let's start with the first one. I was looking for, like some time ago, I was looking for a programming language that is easy to use for audio programming. Like there are a lot of options. There's like the visual programming side, like max and speed, pure data, and so on. Then you have like, some experimental projects like WebChuck, like another one that I can't remember the name right now. Then you have, like, of course, Super Collider and so on. So there's a lot of options. But I was looking for something that's conceptually quite simple. And what I found is called Faust. So Faust is a functional reactive programming language for audio coding. So it's quite easy to express algorithms in it. Like, for example, if you would use C++ and C, it would be like, there's quite a lot of setup that you need to do. You have to compile it, you have to run it somehow and so on. But Faust compiles to a lot of languages, like C, but also WebAssembly, Rust and so on. So, and because it compiles to WebAssembly, I can show you something that runs in the browser. So, one very simple program is to just have an oscillator. Maybe I should make the font bigger. Can you see?
Guys, can we like turn off this light?
The main light.
Yeah, it's making very...
It's glaring a bit.
Не, тази голяма.
Масив система за...
Има, да, с ап.
Nice.
Oh, that's
It's very romantic now.
I'm backing out there.
But this is from the window.
Oh, now it's fine.
Oh, okay. Ah, okay. Cool.
No.
That's good.
Alright. Should I make the font bigger or is it fine?
It's okay.
Alright, so okay. In Faust, like forget about this right now. This is a very simple program. So basically, you just say, I want an oscillator with 440 Hertz, and if you play it, you get 440 Hertz oscillator. Of course, different values, different sounds. Now, if you want to make this controllable, you can just put a slider in. Some values, like the minimum, the maximum value, the default value, I think was first, then the minimum, then the maximum, and then the step. So I think it should work. Alright. So here, now we can control the frequency quite easily. You have like a wave here and so on. So in Faust, there's no difference between control rate and audio rate. Everything is audio rate. So, for example, if you want to have like a frequency modulation, you can just create an oscillator here that's called X, right? And then we have a second oscillator here. So this is the first oscillator with a frequency of 70 Hertz. And the second oscillator has a base frequency of 400, and then its frequency is modulated with the frequency of the first oscillator. So it's going to sound like this, right? So you have like frequency modulation already, and it's pretty easy. Like basically 2 lines of code. Of course.
So basically, this model is expressed like normal mathematical expressions.
Yeah, basically, yeah. I think one of the reasons for this language is that audio engineers, as far as I know, often use like programs like MATLAB and so on to first design algorithms, but then after they design the algorithms, they will have to translate the code into C, for example, so that you can run it in a plugin. And the motivation for this language is you just express the algorithm, and then it compiles to efficient code that you can use in plugins, on the web, like here, and however you like. So I'm just going to show you how the frequency regulation works. Like the slider. Now we have the slider. And we could have a second slider here. Right. Now we have two sliders. Yeah. Nice speakers though.
I was going to say be careful because the quite
Yeah,
big range.
and right next to it.
Yeah.
So yeah, this is the language. You can express everything. Like you have a lot of options. You have reverbs, like the delays, everything that you need in language, in an audio programming language. So here's like, for example, the ladders. You have delays, compressors, analyzers, envelopes, filters, interpolators, whatever, mats, and so on. So for those of you who do audio programming, I would encourage you to check it out because it's quite good, I would say. So anyway, so this is the first thing. The second thing is it's okay to write code, but sometimes you just want visual environments because it's much easier to experiment in visual environments than having to write code and put sliders and blah blah and everything. So what I did is basically package up Faust in a modular synthesizer environment that runs in the browser. So here it is. Okay, so here you have maybe a link. Okay, so basically it's quite similar to VCB rack for those of you who are familiar with it. You have modules and you have cables between the modules, and it's like basically the idea is to simulate the way that you play around with hardware synthesizers. Like you can connect them with cables and then get sound. So let's put an oscillator in, an output. So this is basically what we had before, but now it's visual. So we can play around with it. We can put the second oscillator, frequency modulate the first one. We have different waveforms. And so on. We have different modules, like this is the most simple example, but we have a sequencer, for example, like very basic sequencer, not like yours. You can, let's see, what can we do? Yeah, one of the things that I wanted to do here, that's, for example, VCB rack doesn't have it, but I think there's a way to achieve it. Like everything should be modulatable by everything else. So for example, you have the frequency here, and if you drag the cable here, there appears a little jack here, so you can connect it, right? And now, let's see what happens, I don't know what happens. So, right. I'm going to try to make a second sequencer and sequence here. So basically, right now we have two sequencers. That one modulates the base frequency of the frequency modulation, and the other one modulates the modulating frequency. and they're with different BPMs and so on. So basically, you can do whatever you like in hardware setup. Yeah. So what else can I show? Like, okay, let's show the reverb. Maybe. So this is a basic reverb. And it becomes quite interesting when you get on other photos and think that modulates the size of the reverb. But maybe, okay, maybe it's where it's like yeah, you have envelopes, you have MIDI in, like the usual stuff, what you would expect. One cool thing is, because we're in the browser, you can quite easily use like graphical programming. Like you can write a shader, like a graphics program that can be modulated by some parameter here. Like, or we can maybe have a color one. This is very simple right now, but you can basically write any shader you like and modulate them with modulate them by whatever parameter you like. And yeah, there's one of the things that I wanted to achieve with this project is to be able to write quickly code that you can encapsulate in a module so that you can experiment with it. And so basically you write JavaScript code, Faust code for the audio part, and then you package it up in a module, and then you can just experiment with it in the visual environment. Also, because everything is code, you can use AI. I know there are fans of AI in the audience. Yeah, thank you. But you can, like, for example, this reverb was written like, entirely by AI. So the user interface and the audio code was generated by AI. And one of the things that I want to do maybe in the future is be able to just write, like, I want a module that does this kind of reverb with these parameters, and then it creates your module in the program in real time, and then you can just play with it. Or something else would be to create like the whole patch, right? Like I want 5 synthesizers wired up in this specific way. Please create them for me, and then it just shows up on the screen, and you can play around with it, modify it, do whatever you like. So, yeah, the aim is to be able to experiment quickly and to realize your musical ideas quickly. Like, for example, what I want to do is, I want to 12 kind of microtonal music maybe. So I want to write a module that allows you to create microtonal chords here, and then wire them up to a sequencer or something else, and then you just have microtonal music, for example. So yeah, that's basically it. Do you have any questions?
Can you, again, from the AI side,
Yeah.
I guess the AI working here comes strictly from the code.
Yeah.
And if you want, for example, to upload a specific microtonal scale,
Yeah.
is it possible?
Yeah, it's possible. Yeah, because microtonal scale is basically the ratio between the frequencies, more or less. So you can just express it in code. You don't even have to write it yourself. Like for non-programmers, the AI mode would be very helpful because you just say, I want this microtonal scale, create a module for it, and then it creates the module, and then you can wire it up to everything else. Yeah, so it's possible. Yes.
Can I give a question? Does it run in the browser?
This is in the browser. Yes, it's it's full screen right now.
Nice. Okay. I was just thinking because you had a great idea about, using the AI not only to write individual modules, but perhaps eventually come up with a patch description and then.
Yes.
So we could perhaps think of the possibility of making a standalone app that's a wrapper around the browser, and then somehow allowing users to upload their own modules online, or
The models themselves.
the modules that
Ah,
we
the
create,
modules.
the patches. So
Yeah.
people have access, to a curated library
Yes,
of.
yes. Also an idea to be able to share modules easily, and it's possible like to have a marketplace like VC Direct, for example. We have like the modules, you search for something specific, but because the modules are code, like it would be quite possible to just share the code itself, and then drag it into the app when it's done. There are many ways to share. Like it would be possible to share in many ways.
I think it would be cool to these visual representations to have also outputs. You can combine into something.
Yeah. Actually, the first version of this was for graphics. Like I wanted to have an environment that not like touch designer a little bit, but in the browser and just shader based. So the first idea was to have graphics, like connect different nodes and then produce graphical things. But then this idea died, and then I became a fan of modular synthesizers. And I was like, I had this project like a while ago, so maybe I can just use it for music instead. Visuals, but it's possible. Just needs time.
Also, it would be cool, like projection. To react to music, that you can do everything in one platform. But like imagine you have 10 synthesizers or whatever, in drum machine, they all react in. When the kick drum hit change the value of the whole thing, and the snare change the hue of the whole thing.
Exactly. Yeah. This is possible now because like this is quite simple here. But you can have like inputs for different, like for the hue, for the color, whatever, and you can just connect it. What you cannot do is like connect this thing to this thing right now. But it's possible. Just to be done. I think,
One of the cool things you mentioned is that it's very easy to write your own modules, right?
Yeah.
And you have live reload. So, like contrary to VCV Rack, one of the best things about this is that it's very easy to make your own nodes, right?
Yeah.
Can you show the code of one of the modules?
I can. Let's see. So let's say the sequencer, for example, the reverb, right? So here's the code, JavaScript, right? Maybe I'm smaller. There's a function, module def, not important, and then here you define all the parameters that you need, like knobs, inlets, outlets. With different arguments, like is it polyphonic, is it monophonic, where is it shown in the interface, maximum value, default value, and so on. Right? And here, like this is JavaScript, here, everything. And here is the Faust code. And this is what I showed in the beginning. Where is it? Yeah, here. This is basically this, but wrapped up in JavaScript code. And here you have here's the reverb. So you have pre-delay time, the mix is just dry plus wet. Then you have blah 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 blah. Like just the algorithm of the reverb. And it's quite easy to express. Feedback, filter, damping filter, and so on. So this is how it looks like. This is basically all the code that's needed for this module here. For for this moment.
So it's basically the Faust code plus I/O that kind what are the inputs, what are the outputs?
Yeah, basically. Yeah.
Nice.
So basically, it's a wrapper around the Faust code where you define the user interface. Because Faust generates the user interface for you if you want. It's like this here. This is generated by the code. Like I don't write any additional code for the user interface. Just say slider, but I don't tell it where to put the sliders on. The problem is the user interface here is ugly, and it's not only because the theme is ugly, but because it just orders the elements randomly into the order you define them, for example. You cannot really place them in specific places, which would be nice in like if you want to have like something usable, like here. So here, here basically, you see, this is the user interface. You just say no, blah blah, and then you say here the x and y coordinates. And this is everything you need to do to place them in the module. And this is like grid-based, but you can use pixel values if you want.
Have you implemented like a drag and drop? You drag the
I want to,
then it becomes like control directly.
Another idea, but yeah, there are so many ideas. Like if I show you, if I show you the to-do list.
Yeah.
There you go. But this is like, wait, there was a way to expand it. Like every one of those points is like has 500 subpoints. Okay, maybe not this one. Yeah, there's a lot. There's a lot.
The green one are the ones you did, right?
Yeah. But yeah, a lot of things, a lot of ideas. It just needs time. But there's AI.
What is Music Mouse? I saw it do.
Music what?
Music Mouse it was called. It was one fragment to do with.
Music mouse?
Yeah. Yeah, I don't know.
Ah, I don't know. So
There's a kind of link for it. So.
yeah, let's see the link. I don't know. Sure. Let's see.
Is it safe for work?
Yeah, I think so. It's YouTube, so. Ah, yeah, okay, yeah. This was actually this woman, I forgot her name, but she wrote, yeah, music was.
That rules out an awful lot of tangle and articulation. Has to do with most of the applications for this kind of computing control are thinking a bandwidth of what somebody can play on a keyboard. The whole thing is designed with the idea of recording and playing back and transmitting physical gestures, but what I'm interested in as a composer is really getting closer to the bandwidth at which we can listen to music and, really dealing with information content. So say I run this thing up, right? And I just start playing it. And I want to just put it on automatic.
Yeah, so I mean, there's a lot of cool ideas from like 30 years ago. A lot of cool ideas. Like, yeah, you can basically lose yourself in.
90s.
Yeah, in the 90s. This is 80s. This is 87.
Oh.
Yeah.
All those clips.
Yeah, this is old.
Call this number.
Yeah. Like, one other thing is in the 50s. In the 50s, they did the mother of all demos. I don't know if you know, anybody knows this. This is basically the guy who invented the mouse. And the demo was amazing. Like, there was video calling in the demo. They did video calling. They did hypertext, like HTML and everything. Like, they did it in the end of the 50s, like 59 or something. Mind blowing. So, yeah, mother of all demos. Yeah. Okay, 68. I'm sorry. Not 50s. but this is like crazy shit.
Lack
Crazy
of
shit.
terms, sort of a glossary. Wow.
But anyway, like I don't want to show you YouTube videos. Yeah, that's me. Any other questions?
When are you gonna open source it?
I can't open source it yet.
You're asking the card questions. Like this is the card question. I don't know. Like I went into the rabbit hole of writing my own programming language because I don't like Faust anymore. But yeah, we'll see.